see that? These are your same carbons. You still have the oxygen here. This hydrogen and this OH. See, this is the hydrogen, this is the OH. There's our oxygen there. So our oxygen that's double bonded just bonds to the two, uses its bonds to bond to the two different carbons. So that's what holds those together. Okay? So now that this is our open chain form, it's called D-glucose because of the hydroxyl on this side. D-glucose is also known as an aldehexose. Reason being, this is your aldehyde right here, and there are 6 carbons. The OSC on the end indicates the carbohydrate. So aldehexose is another name for glucose. Okay. So now let's look at the Howard's projections, and all these Howard's projections mean is that you're going to form a alpha and a beta molecule. That's it. So if we're to draw the Howard projection of alpha and beta D-glucose, we're going from this, our open chain. We know it's got to be in a ring formation. The only thing that tells the difference between alpha and beta is the placement of this hydroxyl group. Okay? If the hydrogen's on the top and the hydroxyl's on the bottom, it's an alpha D-glucose. If the hydroxyl's on the top and the hydrogen's on the bottom, it's a beta D-glucose.
The beta pretty much means bottom.
if you're reverting to hydrogen, the placement of hydrogen. Don't get confused and think beta means hydroxyl on the bottom, because that's alpha.
Yeah.
So the way I look at it is H-I-J-K-L-M-N-O. Okay. H comes before O in the alphabet, right? Alpha comes before beta in the alphabet. If H comes before O, it's alpha.
Okay.
If O comes before H, it's beta.
Okay.
So look at it alphabetically.
Okay.
Hydrogen, H comes before O, alpha. A comes before B. Does that help a little bit? Yeah? No? Okay. So the question is a question you might see is how many cryocarbons are there in the open form of glucose? Remember, the cryocarbon is where there's 4 molecules attached to it. And, like, for instance, you can't have 2 hydrogens, you can't have 2 OH groups, they have to be different groups. So, if this is our open chain form, how many of these are considered cryocarbons? And which ones are there?
You said that's the open chain.
Yes, this is open chain form.
Cryocarbon is the one.
Cryocarbon.
Has the one that has 4 different types of elements around the carbon.
Yes, yes. Now, you can exclude carbons in that. If a carbon's connected to a carbon, those don't count. You just worry about, like, as you would say, anything other than carbon.
We have 4, right?
Yes.
1, 2, 3, 4.
Yep. This one has 2 different ones. This one has 2 different ones. This one and this one. This one doesn't because there's 2 hydrogens there. This one doesn't because it's double bonded to that oxygen. You pretty much never include a ketone or an aldehyde in these cryocarbons because they'll always have a double bond. So it can't be different molecules. So the answer to this would be 4. Okay? So, if you go over here, say it asks how many cryocarbons are there in alpha D-glucose. Well, first you have to know how to draw alpha D-glucose. Second, you have to know, okay, now that I've drawn it, this can't be it because there's 2 H's there. Well, this one, and this one. So 4 is the same thing.
Is that how the question will be worded, like on the exam?
This is exactly how the question is worded on the quiz. Exactly. Exactly how it's worded. And I think there's also one that says how many cryocarbons are there in alpha D-glucose?
Okay, so let me see if I can try to remember how to write that so I can see.
Well, here's a tricky one. I told you wrong. How many cryocarbons are there in this one? Well, let's consider this one. That's got two different ones. Let's consider this one. That's got two different. All right, how about this one? There's two different. This one, there's two different. Well, what about this carbon?
That's the picture, right?
Well, this carbon is got
Where it is
one.
attached to, okay.
But look at this carbon.
It's not.
It's not. It's still bonded to a carbon and an oxygen. So that's considered one too. So it would be 5. So in alpha and in beta, there are 5 cryocarbons. Because if you look at it like this. Glucose in the linear form is considered a 5-member, it's considered a 6-member chain, but it's going to have 4 cryocarbons. And see, you can see it a little bit more easier here the way it's spread out. See, it's attached to different things. But this one, it still isn't. This one isn't counted. Just like down here, you didn't count that. But when you draw it in the cyclo form, because you're pretty much adding an extra bond in there to make it round in the cyclo, you get 1 extra cryocarbon.
Okay. So basically when we put the, should we call this a hexane or?
Yeah.
Okay. We put the hexane together, we should add an additional cryocarbon.
Yes, it has an additional cryocarbon. And the reason that is because the hemiacetal, because the hydroxyl bind to the aldehyde here. Okay? Alright, so that's that section. Are you recording?